Hello students, today I am going to talk to you about interpreting the IUPAC name of a molecule which is very important in our body, adrenaline. Now all of us might have heard the word adrenaline before, okay? It's an important neurotransmitter in our body. It is associated with the sympathetic nervous system, which is in turn associated with the excitatory responses of fight, flight and fright, okay? So now, if you look at the IUPAC name of adrenaline, it's 4,1-R, 1-hydroxy, 2-methylaminoethyl benzene, 1,2-diol. I want you to look at the rightmost part of the name, which is benzene 1,2-diol. Okay, the structure is given below. This is a benzene ring with the two hydroxyl groups on C1 and C2 numbered as per IUPAC. Okay, so that's why adrenaline is called a catecholamine. Why? Because benzene 1,2-diol, the other name for it, common name is catechol. That's why adrenaline is chemically classified as a catecholamine. Okay, we'll come to that later now, but for now I wanted to look at the IUPAC name. So what does the IUPAC name tell? It tells us that the main nucleus, that the parent nucleus is the catechol, okay, moiety, okay. And now let us look at the other part of the name, okay. So you see the other part, you can see that on the C4 of the benzene 1,2-diol, there is a 1-R, 1-hydroxy, 2-methylaminoethyl side chain. Okay, so what does that tell you? Once again, I want you to look at the rightmost part of the side chain name, and you can see it's ethyl highlighted in red. So this is an ethyl moiety. Okay, so you can now say that you got a catechol main nucleus, and on the C4 of the catechol or the benzene 1,2-diol, you got the ethyl moiety side chain. Now ethyl moiety side chain we're going to further define. Okay, now let us look at the ethyl moiety, and according to the IUPAC name, if you look at it properly, the IUPAC name, you can see that there's a hydroxyl group, 1-hydroxy. It means the hydroxyl group is on C1 of the side chain, and there's a methyl amino, NHCS3, okay, on the C2 of the side chain. Now notice that you have to number the side chain from the point of attachment. Okay, so you can see that now this is the full structure of adrenaline. Okay, you got the benzene 1,2-diol nucleus, you got the ethyl moiety side chain on the carbon 4, and the side chain itself has got on its carbon 1 an hydroxyl group, and on its carbon 2 a methyl amino group. Okay, so this defines the structure, but we are not finished yet, because now we have to define the stereochemistry of the carbon 1 of the side chain, because it's a chiral carbon. It has got 4 different attachments. Okay, now finally the side chain reveals that the C1 of the side chain, that is finally the side chain to 1R, the name, it reveals that this C1 has got R configuration. Okay, so let's fix the configuration as per the CAN Ingold priority rules. Okay, see, for C1, if you look at the 4 different groups attached to it, the first priority will be OH, second priority will be C2, third priority will be the benzene ring itself, and the fourth priority, hydrogen, is now facing away from you, and you can see that 1, 2 and 3 are rotating in the clockwise direction. Okay, so that is why this gets a 1R or the R configuration. Okay, so this is the proper depiction for it. Thus the full name for adrenaline including its stereochemistry is 4,1-R, 1-hydroxy, 2-methylaminoethyl benzene 1,2-diol. So basically what we got for adrenaline, what does the name tell you of the IUPAC name? Tells you this is how you have to interpret the IUPAC name for any compound, systematically you have to interpret it. So in our case, in this case for adrenaline, it's got a benzene 1,2-diol or a catechol nucleus with an ethyl side chain on carbon 4, and the side chain itself, the C1 of the side chain has got a hydroxyl group, the C2 has got methyl amino group, and moreover the C1 being chiral, it has got R configuration according to CAN Ingold rules. Okay, so that is what I wanted to tell you in this video, and that's how next time when you see any IUPAC name of any other biological compound or any other complex organic molecule, This is how you have to systemically interpret its structure. Thank you.